All right, so we're going to continue on talking about polynomials, but we're going to focus a little bit more on factoring. So remember, factoring is something we saw a little bit already in this unit, but now we're going to focus on some specific techniques and scenarios that we want to look out for when it comes to factoring. So this video is going to focus on the greatest common factor. First of all, let's break down those three words. We're going to start with the word factor. I know this is something we hear in mathematics a lot, and sometimes we just hear our teacher or somebody else saying it all the time, but we really don't have a great idea of what it means. So our definition of factor is, if we have a term, a factor or factors of that term are numbers and or variables that divide that given term without a remainder. So something that divides evenly. So for example, the number 6, the factors of the number 6 are 1, 2, 3, and 6. So one thing to point out is factors of anything, one of them is always going to be 1, and one of them is always going to be that thing. Then there might be some other stuff. Side note, if something is considered a prime number, then the only factors of it are 1 and itself. That's what it means to be prime. So another example, factors of here x cubed would be 1, x, x squared, and x cubed. So all of these would be factors of x cubed. But we were talking about the greatest common factor. So common just means that all of the terms are going to have it, right? They have it in common. Weird. And hopefully you have an idea of what we mean when we say greatest. So we're talking about the largest thing that they all have in common as a factor. All right, so here we're going to do some examples, and we're going to look at just identifying and then taking out the greatest common factor. Now, one thing I will point out, because as we go along in this, when we say greatest common factor, so, greatest common factor, a lot of times we will see that abbreviated GCF. All right, so if you hear me say GCF or refer to GCF, I'm talking about the greatest common factor. So if I want to identify the greatest common factor here, I can see that I have, first focus on the numbers and the variables individually. So I see I have a 9 and I have a 3. Well, 3 is a factor of 9. 3 is also a factor of 3. So when I'm trying to identify the greatest common factor here, I know part of it is going to be 3. I see that this term has an x, this one doesn't. So I can't deal with the x. This has a y, and this has y to the third. So out of those, y is the largest factor of y and of y to the third. It's the largest thing that they both have in common. So the greatest common factor is going to be 3y. So that if I factor out 3y, well, what am I left with? Well, if I factor out a 3 from a 9, and remember factoring is very similar to division, so what is 9 divided by 3? Well, that leaves me with 3. What is y divided by y? Well, that's 1, so I don't need to write that there because of the 3, but I do need to recognize that it's still there, right? Here, I took out the 3. I'm still left with an x, and I took out a y, so I'm left with y squared. So we get 3y times 3 plus xy squared. Great. Let's try another one. Here I have 6 and I have 8. So what do they both have in common? Well, they're both even numbers, so they have to have at least a 2 in common. Other factors of 6 are 3 and 6 that are larger. Remember, we're looking for greatest. But the other factors of 8 that are above 2 would be 4 and 8, neither of which are 3 or 6. So the largest thing that 6 and 8 have in common is 2. So I have a 2. Here I have an r to the third, and here I have an r. So out of those, r is the largest that they both have in common. And here I have an s and an s. So they both have an s. So then I can go ahead and factor out 2rs. And I'm left with 3 r squared minus 4. Now, you can always check this because factoring is the opposite of distributing, right? So if I was to multiply here, 2 times 3 gives me 6, r times r squared gives me r to the third, s times 1 is s. 2 times 4 is 8, r times 1 is r, s times 1 is s. So I can see that that was good. Any questions? Okay, I want you to try to do 3, 4, 5, and 6. So you're just identifying the greatest common factor and then factoring it out. Pause the video, unpause when you're ready to check. All right, so hopefully you got that for number 3, the greatest common factor is 3x. And I see that because each term has a 3, each term has an x, this one has a y, and this one has a z, but neither of the other ones do. So I take out a 3x, and here I'm left with 1. And remember, I was mentioning this up here, right? When we took out a y, I said, well, there's still a 1 right there, but 3 times 1 is still just 3. But we need to put in that placeholder here. So in this case, if the greatest common factor is the entire term, you need to put in a placeholder for that term, right? It doesn't go away. It's not 0 left here. It's still 1 because, again, as I was talking about up here, I need to be able to multiply this back out and get the original thing. And so 3x times 1 will give me the 3x. All right, that was enough rambling. So then here I took out a 3x and I'm left with y, and here I took out a 3x and I'm left with z. Moving on, number 4, greatest common factor is yz. I know it was really tempting to say 4yz, but the last term didn't have a 4. Dang it. All right, so I took out a yz, and then here I'm left with 4y. I took out a yz here, and I'm left with just 4. And I took out a yz here, and I'm left with minus 5y squared. Now, another thing I would point out also, as you're doing these, notice another way you can check to make sure you got the greatest common factor correct is, do I have anything still in common, right? And again, this has a y squared and this has a y, but this doesn't. This has a 4 and this has a 4, but this doesn't. So I know that that was the greatest common factor. Next one, number 5. So here, greatest common factor is AB. If I take out an AB here, I'm left with 5b squared. And then here I'm left with minus 5a squared. And here I'm left with plus 11a squared. And again, I can check and make sure I don't have anything in common amongst all 3 terms. The last one's a little tricky because actually we could have just simplified this first and then there's no factoring to do. But for the sake of the problem, the original problem, if we don't simplify, the greatest common factor is xy. So if I take out an xy from all 3 terms, here I'm left with negative x, here I'm left with positive 1, and here I'm left with negative 1. Again, 1 minus 1 is 0 in this case, just like xy minus xy is 0. So we could do that arithmetic, and then we would be left with just xy times negative x, or negative x squared y. Okay, so now we're going to take this one step further, and we're going to apply just factoring, right? So here, if I want to factor this completely, I want to first always look for a greatest common factor. And notice that each term has an x. So let's take that out. Now, notice that what I'm left over with is something that we've factored before, right? And so in this case, I want to ask myself, I notice that there's 3 terms. And so I can think about, well, what multiplies to negative 5, but adds to negative 4. And so that's going to be x minus 5 and x plus 1. Because negative 5 times 1 is negative 5, and negative 5 plus 1 is negative 4. Now don't forget, this x at the beginning, that's still there, right? So this is my answer. And also pay attention to the fact we are not solving anything right now. There is no equal sign. So I'm not setting these equal to 0 and solving. I am just factoring. So the answer is this. Okay, I want you to try and do B and C. Pause the video. Unpause when you're ready to check. All right, so the second one was maybe a little bit tricky. First, we take out the greatest common factor, or GCF, and that's 3y to the third. So if I take out a 3y to the third, I'm left with y squared minus 16. Now, some of you may remember how to factor this. This is what we call difference of squares, and this is what I'm going to talk about in the very next video. But if you didn't remember difference of squares, another way we can factor this is we can think about, okay, well this is the same as this, except for the middle term is 0, right? So what I was writing here is I can think of y squared minus 16 as y squared plus 0y minus 16. Why would I do that, you might ask? Great question. Well, because now I can ask myself what multiplies to negative 16 but adds to 0. Positive 4 and negative 4. Boom. So I know that this is going to factor into y plus 4 times y minus 4. And then I still have my 3y squared because that was my greatest common factor. So this is my completely factored polynomial. C, I can see that my greatest common factor is 5z squared. So then I'm left with z squared plus 6z plus 9. Now I'd ask myself what multiplies to 9 and adds to 6. That's positive 3 and positive 3. So I can write my answer as 5z squared times z plus 3 times z plus 3. Or we could combine this and write it as 5z squared times z plus 3 quantity squared. Either way is correct. Okay, so what we focused on here was greatest common factor. Anytime you are trying to factor, simplify, or solve something, always look for a greatest common factor first. It will make everything else much easier.